1, 2, 3. It works. All right. I have 3 demos to give today, so we'll see. The demo gods should be on my side. So you might be wondering what a talk on protobuf and gRPC is doing at a JavaScript conference. Some of you have touched these technologies before, and some of you haven't tried them. But maybe you found them painful to use. So it's time to give them another look, and I'm going to tell you a little bit about what protobuf and gRPC are, and the problems they solve, and why they're much more usable on the web these days. So for anyone who's about to walk out, if I say protobuf one more time, the 3 most important takeaways for this talk are that protobuf and gRPC are the best way to do cross-language APIs. They are finally ready for the web, and they're as productive as tRPC or GraphQL, which also, those are the demos. So there's going to have one for tRPC, one for GraphQL, and one for this protobuf stuff. So first of all, hi, I'm Dimitri. I'm really passionate about TypeScript, and as well as API development. I used to work on this thing, Insomnia, the API debugger. But these days, you might know me as the guy solving all the TypeScript type challenges with Michigan TypeScript on YouTube every day between January 1st and June 1st this year. Some amazing people have joined me, like Matt Pocock, Theo Brown. Oh, wait a second. Hold on. That's not going to work. Demo gods, be with me. OK, here we go. All right, so that's the challenges. How many of you have done the challenges before? You know about them? A little bit? OK, well, anyway, we got some cool people that are with me, and also Anthony Fu, who you're going to hear speak tomorrow. OK, so this is here we go. And I work at Buff. So at Buff, we're bringing the productivity of typed APIs to every developer by moving the protobuf and gRPC ecosystem forward, especially for mobile and web developers. All right, so what is protobuf, and how does it do this cross-language API thing? So the classic alternative is handwritten HTTP and JSON. This was fun in 2005, but now it's just a little tedious, and you spend most of your time on trivial details that don't actually matter to you or your users or your business. For example, you need to create all of your clients and servers, and they all have to agree on HTTP methods and routers, on response and request types for each endpoint, and how errors are going to be communicated. Then you got to make sure that the clients and servers stay compatible as the system evolves over time. It's a hassle. So imagine we're building a to-do app with a TypeScript web client and server. We start with a to-do interface in TypeScript. You see that on the right. And then we decide on the URL scheme for creating a to-do, and we're pretty much done. The server and client can share the TypeScript code, and they just use JSON stringify and JSON parse and fetch to send and receive data. But what happens if our mobile team wants to write the iOS app in Swift? They'll have to duplicate the routing code and the to-do definition, including the docs. And it's bad enough with simple types like strings and booleans, but it's really painful with more complex types like big ints or dates. So for many of you, this is the natural evolution of your product. You start on the web, and you quickly need to support more clients and more platforms. So now imagine that your backend isn't scaling really well, and your team decides that you want to rewrite it in Rust. Once again, you're repeating the same routing and to-do schema in yet another language. If your company doesn't use TypeScript on the back end, you might start in this position. Okay? So it's already feeling a little tough to manage, and you might soldier on with your handwritten TypeScript and Swift and Rust and trying to keep it in sync. Then there's this one. How should the URL look when we're fetching multiple IDs? Maybe we're HTTP purists, and we pass the ID as a parameter more than once. Or the second one here, maybe we want a more compact format, so we comma separate them using the single parameter. Or maybe we're too exhausted to debate with our colleagues about this, and we just shove some JSON in there and call it a day. The point is, this decision doesn't matter at all. At the end of the day, we want to send an array of some things to our server, and instead of being able to just do that, we're stuck in the weeds of HTTP. And because there's no standard way of doing all of this stuff, we're again forced to hand update every client for the routing logic of our new endpoint. So this kind of cross-language API development in gRPC and protobuf is the sweet spot. By choosing better tools, we can replace our handcrafted HTTP routes and manually synchronize data types. And the schema isn't exactly the same as our original TypeScript, but it's not far off. It's just a data bag with some typed fields and then a collection of functions to operate on that data. In return for switching to protobuf, we get rid of all of the cross-language pain. So let's dig into how this actually works. So protobuf is a schema language. It's designed specifically for describing data and APIs. It doesn't include anything else. So you can't implement your API in protobuf. Instead, you use the protobuf schema to generate code in your language. Protobuf calls your data bags messages, and in our to-do example, we had one to-do message, but if there were more, then we would just have more things that were generated by the toolchain. And these classes come ready-made with methods to serialize to binary or JSON. No matter which option you pick, the complex data types, like I was telling you, like big ints and dates, are handled consistently in every language. So let's see what it's like to do this in TypeScript here. So on the left, you see the to-do schema we saw before. And on the right, you can see how that same code would look if we have it in TypeScript. So you can construct new to-dos like you would expect. You can serialize them to and from JSON or binary, your choice. And remember, you can generate equivalent code in any language that you want. So this code isn't tied to any particular network APIs. You could read it from a file. You could write data to Kafka. It really shines when you pair it with gRPC, though. Protobuf takes care of the code generation stuff while we used to have to write by hand. And gRPC solves the other half of the problem, the low-level HTTP boilerplate. It takes abstract APIs. It takes an abstract description of an API, and usually from the protobuf schema because it's the default, and specifies what HTTP method, path, and headers the server and client should use. So it kind of like negotiates all that stuff for you. So in this situation, we'd generate two things. We would generate a server and a client, but it could be any language. The server is just a skeleton. It takes care of all the gRPC takes care of all the low-level stuff, and we're just filling in our API's logic at that point. You'll see this in the demos. So our generated clients are completely hands-off. They're ready to use immediately. So whether our backend is TypeScript or Python or PHP or Rust, anything else, we can trivially support clients in any other languages. Want to support a Go client? We don't even need to know Go. We can just generate it. So it's pretty cool. And this is how the service looks in protobuf. It's an abstract description of our to-do, so it just looks kind of like a function, right? You have these inputs and outputs. We don't have to mention any of the HTTP stuff. Like, there's no mention here of methods or paths, right? And on the right, you can see what it looks like to create a to-do over the network. The client has this method matching the schema, and each method accepts object literals as you'd expect. You don't see routing or serialization data anywhere here. We just await on that promise, and we get back a type for whatever our API returns. The TypeScript types here are all automatically inferred, too, which is great. So under the hood, gRPC is just HTTP, and you can do anything you'd normally do with HTTP. So you can do like authentication, authorization, headers, tokens, rate limiting, load balancing, session affinity, all that kind of stuff you can still do, whatever. It's the same. But in this example, we're sending an auth token in the header, just like you would for any other HTTP request with fetch. So dozens of large companies from Spotify and Netflix to Cisco and IBM rely on protobuf and gRPC in prod. There are plenty of big open source projects that also depend on protobuf, like Kubernetes, etcd, and TensorFlow. But despite accelerating adoption, these technologies haven't been common on the web. Why do you think that is? It's like, what's going on here? To put it bluntly, protobuf and the gRPC ecosystem didn't prioritize the needs of TypeScript and JavaScript developers. The JavaScript protobuf implementation was incomplete. To name a big one, it didn't support JSON in JavaScript. Like, that would be the first thing I would do. I don't know. It produced huge bundles, and it had kind of lackluster TypeScript support. Okay, so on the gRPC side, the protocol itself is just incompatible with the web. It requires HTTP2 and critically depends on some obscure features that the browser makers don't want to support. And working around these problems requires running a C++ proxy in front of your server, which is not fun at all, especially if you're developing locally. It's a lot. And then on top of that, you can't distinguish errors using HTTP status codes. The body data isn't human readable. It's a few things. And this all builds to a situation where gRPC is pretty difficult to debug. And if you've tried using protobuf and gRPC in the past, you've probably run into all of these things. They're really painful. So luckily, the problems are in the past now. Buff is trying to modernize protobuf and the gRPC ecosystem by starting with mobile and web development. And let me introduce you to some of the libraries. So the foundation of our stack is protobuf ES. It's a complete TypeScript first protobuf implementation, and it supports JSON binary, produces tiny bundles, and is fully compatible with protobuf in every other language. So then to actually call your APIs, you use protobuf ES together with Connect Web, our replacement for gRPC. All this stuff is TypeScript first. At the same time, it's fully compatible with any gRPC web backend if you've used those before. And more importantly, it supports a new web-native protocol called Connect that's just as fully featured as gRPC with none of the downsides. The Connect protocol works with backends using Connect Node or Connect Go, and it's all underpinned by protobuf. Finally, we worked with Tanner Lindsley and the JAMstack team to integrate JAMstack Query. We made Connect Query. So Connect Query makes type-safe state management really easy, and you can use it in React if you're using React Query or Vue or Svelte or solid.js. All the JAMstack stuff that's supported. So with these three components, a modern protobuf stack is just as productive as tRPC or GraphQL. To show you what I mean, we're going to look at the same to-do app, but built in these different frameworks. So let's do the first. I need some water. I don't speak Dutch. It's either water or vodka. We're gonna find out. Water. OK. So tRPC demo. All right. So I made this. You can see it. Great. I made this little thing here. We're going to use this to look at the back end. Let's just start. Oh, I made a little. Oh, what am I doing? I have a little cheat sheet. OK. It was the vodka that threw me off. So, all right, let's look at our app just like front and center. Get the code out of here. Where are we going? All right, here's our app. So it's exactly the same app written with just the, like, you remember we used to do in React, there was like a view component and a container component. It's not trendy anymore. But what I did is I separated the view, so we're just going to look at the container, like the logic working. So you're going to see three things. This is actually Connect. So let's go here to it looks exactly the same. This is tRPC. And what I want to show you is I can create a to-do. So let's do like speak at JSWORLD. Oh, well, YOLO. OK, there we go. And we see that as soon as we did that, we get this get to do thing that pops up here in the tab. And we can look at the payload and preview it and see that it's just JSON. And this was sent all with tRPC. And we see the response as well. OK. So also notice that we have the React Query DevTools. That's what this stuff is here on the left, on the bottom. And very handy. If you've used them before, they're super great. So let's go over and look at the code. Which way is the code? There we go. So this is the code. This is the backend. tRPC uses Zod. So we define all those types with Zod. We can use z.infer to grab a TypeScript type, which is pretty much exactly what we would write if we were writing it by hand. I made sure to include. I'm trying to show all these in their best light to give it a fair look. But I did find there's a way that I wrote the type here. If you hover over it, you can't express literally everything in Zod. It's pretty close, but TypeScript is Turing complete. We've got like SQL engines and JSON parsers being written in TypeScript. I don't know why. And so there will be situations where you hit things that you can't express even with Zod. Same for protobuf and the rest. But it's very, very good in general, and they all work this way, including GraphQL. Let's look at the front end next. All right, here we go, tRPC front end. So notice that we still did have to write a schema, right? Zod is a schema. It's just a schema in a programming language. It's also validation, but it's like the combined IDL of Zod and TypeScript or any other. I guess it's pluggable, but it doesn't have to be Zod. But that's the schema of tRPC if you want to think of it. This is the back end. So on the back end, we see we have this invalidation step. This is just so that when we get data back from the server, we don't have to make another round-trip request in order to fetch the to-dos again. Not strictly necessary, but it's a good thing to do. We have our create. So, and then this is our view. We're going to see this. I'm going to hide it from you, but that's basically the implementation. It has this use query, use mutation type API. So if you've ever done React Query or tRPC or any of the things that have this API, actually the GraphQL does as well, we're going to see that. Speaking of which, I think GraphQL is up next. Oh, I wanted to tell you about tRPC. So like tRPC's got a lot going for it. It's a simple mental model, and it makes your TypeScript functions available over HTTP directly, which is super nice. Everything's strongly typed, and you only need to write TypeScript. But that right there is the most important weakness. If you ever need to support a non-TypeScript client, you're back to hand synchronizing code across languages. GraphQL is often known as like a cross-language solution for this. So let's see what GraphQL has to offer in this case. So let's go to our app. Where is it? Here we go. I think this is the one. So there's no React Query DevTools here because there's no React Query. But we can do GraphQL. So let's just like update one. I'm going to check that one off, learn protobuf. Hopefully we did some of that today. And we can see here that we have a query. It's just a string. It has this operation name thing. There's no variables for this one. And we have a preview of what was sent. Let's look at it, get to-dos. Or this is what was received, rather. And so we see that our to-dos were sent back to us, and one of them is completed true now. OK. Let's go look at the not just strings. Yeah, let's go look at the base server. OK, so this is the GraphQL schema. It's not the spiciest GraphQL schema you've ever seen, for sure. It's just a CRUD schema for a to-do app. But in the bottom here, you can see that we defined our kind of functions, right? We have get to-dos, create to-do, update, and delete. GraphQL has you separate mutations from things that are not, but it's pretty straightforward. I'm not sure there's much more to say there. And then we can look at the base implementation that's generated from that. So you take that schema and you generate TypeScript code. You then run that TypeScript code in production when you're developing locally. And this is what it looks like. We're not going to dig through it, but it's generated code. It's not terrible. It's not great, but it works. So we're happy with it. From there, let's take a look at the backend. The backend is also like Mondo unspicy, but here it is. This is just Mercurius, and it just uses those database types. I forgot to show you the database. It's not like it's not a super big deal, but we have a database. Is this, wait, create to do, oh, wait a second. Well, anyway, there's a database little thing that I made in-memory database, and that's what these functions are. It doesn't matter. I just want to show you kind of like how it feels to use it from an API perspective. Very nice. And then, yeah, let's look at the front end. So here's the front end. Did I click the right thing? GraphQL client? Oh, I just scrolled down. OK. So here's the front end. It starts off with the GraphQL queries. This uses the GraphQL syntax. So I have an editor integration that puts that syntax in a nice way on the screen so it doesn't just look like a string. But we can hover over the types here and see that we have this get-to-do query type. And it's pretty nice because this stuff is kind of done automatically for you, but you do have to run a command in order to generate this. In fact, I can show you, I'll show you after we look through this file what that command actually does. And here we have the queries and mutations. So it looks very similar once you get past the point of writing all the boilerplate. It's not really fair to call it boilerplate because that's how it is by design, but that's the GraphQL way to do things. And we have our updaters and deleters. So it's all here. Let's take a quick look at this lib thing. So you can kind of get a hint for what's going on here. It's putting the entire string of what was passed to that function directly. It scans your code and then writes this type. And you know, if we go back to it, you'll see that all this stuff I showed you, it was type safe and complete. But if I just add a space there, we get, move it, we get unknown. Womp womp. It's fine. You know, you would run it in a watch, but that's how this works, code generation with GraphQL. OK, so let's go back here. So GraphQL offers a lot of flexibility, but that flexibility comes with a lot of complexity. The mental model has a lot of moving parts. And rather than calling functions over HTTP, we're exploring a graph of linked entities. And even though we've taken the time to write a schema, queries are just strings. So, and because the underlying model moves so far away from the request-response HTTP way of doing things, previously solved problems like caching and rate limiting and authorization don't have a clear answer. And I've seen backend teams be reluctant to adopt GraphQL, especially when the SOC 2 compliance people come knocking. OK, so some of you may know those guys. OK, perfect. So let's look at Connect. Let's look at the modern protobuf demo that I was telling you about. Here we go. So this is the app. Let's take a look at that. So it's also using Connect Query. So we get the React Query DevTools for free, which is super nice. And let's delete one. So learn protobuf. Why not? We see here that we got a network request in the tab for delete to do. I want to bring your attention to the point that this is JSON. It's not protobuf binary serialized gobbledygook. If you didn't know what to expect when you heard that we're doing protobuf, you might say, like, oh, it's unremarkable that it's JSON. It's actually super cool that it's JSON because all the benefits of the schema are still there with us. You don't have to be using the binary serialization to use protobuf. You can use JSON in this way. I see sometimes if you look online or listen to discussions of people talking about protobuf, they'll say, like, if you have to use protobuf for your app's performance, because protobuf compresses it, we didn't talk about it, but protobuf compresses the data a lot, they'll say if you have to use protobuf to get your app to work well, then you're doing something wrong. And it kind of misses the point. Actually, the power is the schema. And you could use JSON just as well as anything else. So it's kind of cool. I like this part about it. Let's look at that schema. So here we go. It's pretty similar to the GraphQL schema that we saw before. We have this to-do thing here. It has a name and an ID and a completed. So this is like what we saw before when we were looking through in the examples. the point here is this is just protobuf. You don't need gRPC to do this. It has a lot of other features that I don't have time to talk to you about today, so there's like some backwards compatibility stuff. At the conference here, some of you have stopped by and told us that you have mobile apps, and backwards compatibility is something that you struggle with because your users could take forever and ever to update their mobile app, or maybe you have someone could keep a browser tab open for a long time if they want. So it's the same sort of thing there. But moving on from that, let's look at what was generated from this. So the base type stuff, this is kind of similar to what I showed you in GraphQL. This is some kind of implementation agnostic helpers that are kind of taking the protobuf and turning it into something that JavaScript can understand. So I told you about from binary and from JSON. This is the way that this happens, is you generate this code. This is live running code. And personally, this is the thing about protobuf that I'm the most passionate about. The protobuf schema, the protobuf code that's generated cannot be wrong about what it gives you on the client side or on the server. It is the source of truth. So compare that to something like OpenAPI, where the spec can lie because it can mismatch what's on the server. It's like an extra step to write the OpenAPI spec. You know, you put it on your bug tracker, and it sits there for months, and you like kick it every sprint to the next sprint. This is not like that at all. You write the schema, and the schema is the source of truth, and it generates the code that you actually run in production. It cannot be wrong about what it tells you because it won't serialize. So it's super cool like that. There's no one-to-one mapping either of generated code to the schema, right? So if you have a server on the back end, you might choose a generator that generates really, really fast code. It's optimized to be fast at the expense of the bundle, because you don't care. It's on the back end. It can be bigger bundle. What difference does it make? But on the client side, where you care quite a lot about the bundle, you might pick one that's still 100% like correct, but has a much smaller bundle size so you can ship it to your clients. So it's not just a one-to-one thing. There's a lot. You can generate documentation sites. We don't have time, but I would love to show you more about that. It's very exciting. OK, where are we going? Here we go. So we saw the base types. Let's look at the backend. So I told you about cross-language. This backend is written in Go. It's not a Go conference, but it's kind of idiomatic Go, like what you would expect to see. I didn't bother, because I'm not using the database, in-memory database stuff in more than one place. I didn't bother pulling that out. So I just want to draw your attention that like basically these last lines are the ones that matter. Like, you can sort of read this code even if you don't know Go. We're taking in some array, we're appending to it with a single item, and then we're returning it. And we're using the helpers that were generated from the schema in order to do that. So we don't have to do any of that work. It's just picked in. I'll show you on the front end, because it's easier to see there. All right, here's the front end. So this is it. This is our front end. We're using Connect Query, like I said. It looks extremely similar to what we saw before, which is good news, because if it looks familiar, then there's a lot of difficulty that you're not going to experience when you're trying to adopt this or bring it in, fold it in. We're using this use query, use mutation syntax, just like we were before. And all the data types are here. So like if I hover over data, to-dos or undefined is what shows up. To-dos was defined by the schema, by the protobuf. It was never something that I wrote in TypeScript, but here it is. I have it in front of me. And this get to-dos helper here came from generated code. Let's take a quick peek at the generated code. We're doing OK. So this is the generated code. It's really simple. So if we look at the app, we've kind of already seen it, but we're going to see the same kinds of things happening. And I want to just bring that point home that it all kind of works together as a function that you call on the server. That's kind of how it feels. You're like doing a function call, and all the other stuff that's like that applies. OK. So with this modern protobuf stack, we can keep most of tRPC's simplicity without tying ourselves to TypeScript forever. And the mental model stays simple. It's just functions over HTTP. From our generated clients through our state management, we get fully inferred TypeScript types. The best part is we can generate production-grade API clients in any language without needing to write that boilerplate. And we think this is compelling. Yes, you're trading away handwritten TypeScript types, but for a similar length protobuf schema, what you suddenly get in exchange is an API that's way more capable. Of course, we still got work to do. We've got Connect Node, which you can use to build your backend in TypeScript and protobuf. It supports legacy gRPC clients and Connect protocol and works over HTTP 1.1. We're also working on shipping Connect for Swift and Kotlin. So if you ship mobile native apps and you want to use protobuf, it should feel as effortless as it would in React Native or anything else. And very, very quietly, too quietly to put on a slide, we are exploring how to do this system using the GraphQL kind of mindset so that you can do batching and filtering and joining, but with the tool of protobuf and RPC. So why not aim for the best? So I hope this talk piqued your interest. When you're starting your next protobuf project, or I'm sorry, when you're starting your next project, make it a protobuf project. Yeah, why not? And these are the best technologies for cross-platform API development, and they're finally ready for the web. So they're just as productive as the alternatives. And many people contributed to the projects I showed you, so special thanks to Timo Stam, Steve Ayers, Gilbert Wong, Paul Sachs, and of course Tanner Lindsley and Derek Perkins on the rest of the JAMstack team. And if you're interested in protobuf or gRPC, or you have any other questions, come talk to me at the Buff booth here at the conference. And even if you think all of this stuff is completely wrong, come talk. We would love to hear from you. Thank you. Okay.